So before starting, I would like to give you a brief about what we are covering in this presentation. So the first and foremost will be the concept of highway engineering. In this one, I'm trying to explain you about the highway engineering concept, what it is, what are the different kinds of uh, parameters we use in a technical terms for a highway engineering. Firstly, it will be a definition of highway engineering. Next, I will be explaining the classification of the roads and different types of payments and the geometric parameters which we involve in this highway engineering to design a project. Which has the subparts as well, like cross section, super elevation, visibility, or side distance. So those are the parameters. I'll just briefing up. And moving along, we just also see through the basics about traffic engineering, highway materials design, highway designs, highway drainage, road marking kind signs, highway maintenance, and how it helps in economics and finance in a region or for a country as a whole. So those are the parameters about highway concept I will be trying to explain you in this presentation. So moving along, after the brief introduction about highway engineering, we just chip into the highway engineering design using the Autodesk Civil 3D software. So I'll be giving the overview of how the application looks like, and I would like to tell why we emphasize more to use this application for our highway projects. What are the advantages it will be there compared to the other competitor applications. So once we have covered that part, I'll get into inner parameters of Civil 3D applications, which we will be discussing about the introductions and its labels and styles, how it will be displaying the parameters of highway engineering, or like you all know about the highway plan, highway profile, highway cross sections, how will be looking. So how we'll control those aspects using these label styles. Those parameters I will just try to brief about. And I will just next I will be jumping into the survey data input, how we from the field, whatever the data we receive to the design, how we import, what are the different parameters of the data will be there, different formats. Those I will be trying to brief up. And I'll just next step will be the process, the template, what you can say, of highway design, how it will be carried out, like the DTM creation. Next will be the geometric design. After the geometric design, the modeling, how it will be done, super elevation analysis work, how it will be calculated. Next, finally, the how will be report will be generated, and also some other important features I would like to share in this presentation. So moving along, I will also explain you about the case study, one typical project I would like to share to you. Whatever the template I have just explained, how we create the DTM, geometric analysis, the corridor modeling, all those factors will be carried out in a stepped manner, so that the project will be executed very smoothly, and the data what we receive and what we calculate, what we design, will be accurately measured and given to the client for this final submission, and for of course for the construction of the site. So here in this case, I'm using a typical interchange design, where it was a intersection. It was a junction before, and we are converting into an interchange. Further, I'll just explain in detail about this case study. So finally, the table in the table of content, what topic will be there is the Autodesk platform. Of course, we need to install this platform in application platform to work with the projects, and also where we can approach this one, how will be the process of that part will be, that I will just try to get into the brief about that one. So we quickly move on to the concept of highway engineering in the prior place. So what is highway engineering? So the typical basic definition I would like to say to you: the highway engineering is a branch of civil engineering which deals with planning, design, construction, and maintenance of highway and its regulations and control devices employed in the highway or train traffic operations. So basically, the highway engineering is about planning, because planning in both is a very integral part of the highway engineering. Maybe you are constructing a new road, or maybe you are expanding a wide road, which is a brownfield, or a greenfield, which is a new alignment you are making. So planning is very important part in this highway engineering. Without the proper planning, you can't do any further process in this field of engineering. So once this plan is concerned with the client, or with the contractor, or within the consultant, or the region, or the stakeholders who are all involved, we come to the conclusion that yes, we need to construct a road from this point to this point, or we need to widen the road, we need to change an alignment along this road. So all those initial stage is very important for any concrete steps to be taken. Once that planning is done, then the next step will be of course the design stage, which we think very important parameters in the construction of the highway engineering, because without any proper design, you will definitely lose a lot of manpower, lot of economy, lot of a lot of other natural assets as well in the construction of the highways, because it involves going onto the field and doing something to the ground there. Exact ground, we need to change the ground basically, I mean to say. So for that one, we need to be very careful of in the design aspect, so that proper design, like filling or cutting, as an example I'm saying, will be taken care in the design part. Uh, how many earth has to be moved, how many earth has to be filled, how the alignment has to be changed depending upon the scenario. Like if you are come across any reserve forest land, or any lake or pond, any monuments, those are the parameters which come along the in between the highway. So we need to manipulate them, or give a proper respect to those factors, and we need to try to design that parameter. So planning and designing are the very basic and very important crucial steps we need to follow in the highway engineering field. Of course, when these two has been done, construction will be the very of course it is a physical part of the job. So it will be very easier, I would say, if these two parameters has to be properly handled. So then when the construction is done, of course the maintenance is also a very important role, because once the construction is done, if you just leave the road for its way, it will deteriorate in the coming years. It will definitely lose its strength, stability, and its potential for what it is designed or constructed. So maintenance also will be the important part in the highway engineering. So basically all this put together, if we need to gel it together to make a highway a very successful unit for the development of the country, or for the safe journey of to and fro from point A to point B. So that is very important factors. So the classification of the road. So coming back to the after the definition, I'll try to touch about the classifications of the roads. So in this case, I'm taking a typical example of India's classification of the roads. So in India, as per the MORTH, Ministry of Road and Transport Highways, roads are classified into this format, what you see in the screen, like expressways, national highways, state highways, district roads, which is again bifurcated into major district roads, other district roads, and finally village roads. So these set of roads are been controlled by different authorities at different stages. If it is a national highway, it is controlled by the central, or the expressway also is controlled by the central government. And coming back to the other subcategory of roads, it will be controlled by the different departments. So those will be the clients who are handling the whole the sectors of the roads, even from planning to design to maintain construction and maintenance. So we need to keep in mind about these parameters also, while we are giving the proper designs of these highways as well, because each classification of the roads has different set of codes to be used in this design purpose. So next, moving on to the types of payment. So we have, as I said, different classifications of the roads. So all the classifications of roads are broadly classified into two varieties. One is flexible payment, and one will be the rigid payment. Flexible payment, of course, the materials used will be the bituminous material, and the rigid payment will be, of course, the concrete materials. So these are the broad classifications of the road, wherein types of materials are used for different kinds of payments. So depending upon the type of payment, different design of payment are also required using the different codes. The codes are generally, depending upon the country to country, different codes are will be there. Like in India, we are using the Indian Road Congress as the standard codes for any design and development of highways. So next, coming to the geometric parameters of highway engineering. As I was mentioning in the design stage, this will be the crucial part of any highway engineering design. So this will start the template of how the road designs will be taking forward. So first and foremost will be the horizontal design, which is nothing but a collaboration of geometries, I would say, like straight, curve, uh, transition, which is like starting from zero radius to the curve radius. So those are the features we geometric sections or elements we attach together to form an alignment to it. So it may be a straight curve and a straight within between the transition, or it may be a straight curve and a transition. So it depends completely on the type of sections we are designing. If we are designing an expressway which has a broader radius, and if you are designing village road or a major district road which has not that much bigger radius, we need to try to squeeze in 2-3 radius to make it a sharp turn. So it purely depends on the classification of the roads what we are designing in. That all again we're coming back to the codes which we are using. Different types of road classification, as I mentioned earlier, has different set of code values for them. I would show the what are the different radius to be used in future further slides. So that comes up to the joining of this horizontal alignment. We fix these horizontal alignments completely depending upon the uh, two types of alignments. One will be the green field and then one will be the brown field. The green field is a new alignment where we are giving completely a new section from point A to point B, where we try to avoid all the parameters like a reserve forest or a lake or a village coming in between, or habitation which is coming across. So those we will try to avoid in this horizontal alignment. And we fix the alignment. So similarly we would do it for the vertical section as well. So vertical section is nothing but the cut sections of the horizontal alignment. So in this case you are looking this from the top view, and here in this case we are looking from the side view. So that is the difference between those two sections of how we are approaching this section. Here also, depending upon the so types of classification of the road, different grades will be given. Two straights are called as grades here, which is connected between the curve, which may be a sag curve or a hog curve. Sag curve will be to downfall connecting to a point which is called sag, and the hog will be the upper gradient and down gradient which is meeting, which is called hog curve, or a valley curve, or those kind of parameters will be used for this design of the vertical alignment. So again, this will be depends on the classification of the road or terrain of the road, I would like to say. If you are designing a vertical place in a plain area, that much minimum grade we can give, or if you are designing it in a hilly section, it will be a completely different ball game. So all those factors will be come into play in these geometric designs of highway engineering. So why we need to give this geometrics will be important factors, because it plays a very important role in designing the safety of a traveler on the road. Because if we are not giving a proper geometry, the ride will be very unpleasant and unsafe for any person who is traveling on the stretch. So to make a person's travel from point A to point B pleasurable, we need to follow all these parameters so that it will be a safe and a renounding journey in the highways what we design in for the projects. So here is a table I would like to share, which is from the UK standards like called DMRB, which is a design road for roads and bridges. Design manual for roads and bridges. I have summarized what are the important parameters we use for the geometric design of horizontal as well as the vertical sections. In the left hand column, you can see the particulars what we are trying to achieve here, which has the design speed. We have different design speeds here, which is again converted into miles, and we have stopping side distance for that particular design speed, and horizontal curvature minimum what we need to provide for this design speed. And one step below to the minimum with the super elevation of particular value, what are the things we need to provide? And again, which is different super elevation, we can change the curve radius to the into our design aspects. So those are the applications we can use in these parameters. So what we need to try to understand is we can't memorize all these values in our mind. So what we do is keep a chart in our design table, or the best scenario, what I'm trying to say in this application will be, we can just feed this value to the application. The application takes care, the civil 3D application takes care of this value, and it gives a reminder to us if we are deviating from these design values, so that we can optimize this value, design value, and keep this design value standard for our designs as well. So again, this will be the vertical parameters what we are using. So what will be the KVL? KVL is nothing but the geometrical conversion of two grades, and uh, to be used in directly, instead of the larger value what we receive in the radius of the vertical curve, we are just converted into the K, the value which is called K, which is constant, uh, so that we will directly use it from the code. So we won't go back and calculate what will be the K value in different grades for different and all. So we just take the speed of the road, and the grades what we need to achieve. So what will the K values will be coming for this particular sag or the hog curve. So those are the direct approach we will be making in the corporate designs, so that it will save a lot of time in the designs, and also we can just go for the drawing, or product drawing productions, or completing the projects with minimum effort and using this code. So these codes are very important to follow in the any highway projects. Maybe it is a greenfield project, or maybe it's an improvement of the existing projects. So that we need to take care in mind while we are designing the highway engineering projects. So yeah, so once the geometry is done and how we are fixed the horizontal and the vertical alignment of the road, next comes the important parameters, which is cross sections. So it will be the body of the road. Basically, once we finalize those aspects of our horizontal highway, so we need to decide the type of cross sections what we need to provide. In this example, I'm trying to share you the single carriageway cross sections, where we are having a typical traffic lanes, different kinds of um, layers of pavements, which has its own specifications and importance to be maintained in the highway projects. So coming back to the carriageway here, it will be the traffic lanes will be important feature of the carriageway. The other part will be the shoulder or the verge, what we call, that also will be plays an important role, and a side drain which we need to provide to collect the water, whatever falls onto the traffic lanes, that has to be provided. In this one below will be the pavement layers. Maybe subgrade course will be the base formation, and the subbase, base, and the wearing course. So all these different layers of pavements have been provided. If it is a concrete road, it will be a different scenario to be maintained. So depending upon the type of payment we use, and the parameters we use, we decide the cross sections with various factors. So this is one such basic example I would like to show. So once we done with the horizontal and vertical, we go for the cross sections design and construction. In the cross-section design, we just come across different analysis which put forward with a couple of analysis. Main analysis what we do, I would like to display in this presentation. The first and foremost will be super elevation. Many of you been aware of traveling in the road, experience this kind of force while we are going on a horizontal curve. You may be experiencing a pulling force, which is uh, pulling you from away from the road, actually, to the sideward directions. So that force is called a centrifugal force, which is pulling away from you from the center, because of the drag which we are experiencing while we covering this section. To avoid this force and make the journey along the curve smoother, we provide a concept called super elevation, where we will try to raise the outer edge a bit higher from the inner edge. That also depends upon the various parameters. I'm not going into detail about that parameters. So depending upon those code values, we'll just raise the outer edge of the carriageway a little bit, as you can see in this image, where we raised the outer edge a little bit so that the inner edge will be at the same level of the road, but the outer edge will be a little bit higher. So once we travel along this road, that force will be minimized or countered, so that traveling will be easier. So that's the concept of super elevation. All those values will be taken from the codes again to achieve this super elevation. So next, one more parameter of road safety precautions will be visibility or the side distance. So in this slide, in what image you are seeing will be the junction visibility, what we need to achieve. So it's a, if it's a typical case and tricky situation where we don't have any traffic light to control these junctions, and if you are traveling on this junction and you are not have the visibility of the other road vehicles which are coming, so at this point it will be very important to give the minimum side distance length for any particular junction design, and also the obstruction vision. So this vision, which is called as a visibility display line, what we call, should be minimum, so that the vehicles can vehicle driver can see what's the other roads, is there any vehicles coming along the other roads or not. So again, this distance, depending upon the type of junction, type of carriageways, all these parameters will include designing this distance as well as the visibility display distance. So that all being provided in the code. I'm just trying to explain the concept about it. So we need to provide a certain distance, certain visibility display length to maintain the standard of the intersection design. So again, in this case, in this slide, we can see the side distance what we need to provide in the horizontal curve as well as the vertical curve. So these are the two other factors where visibility will be tricky situation. So we need to provide that one. So next we'll be moving along the traffic engineering. So traffic engineering is one big factors apart from the geometric design and what I was trying to explain. So traffic engineering is nothing but deciding factors of many individual things in the highway projects. Like for example, how we decide the carriageway width, how much lane we required for a particular stretch, that's calculated using traffic engineering. How we decide, is the junction require a signalized junction, or we can control the junction using the traffic signs or road markings, or you need an interchange, or you need a roundabout. All these factors are decided by traffic engineering. So it is a very important branch of highway engineering where we use all these techniques to decide the parameters of the road or intersections. So that calculation is very important, so for doing the highway design part as well. So I'm just briefing about those parameters. So as I was saying, traffic engineering is very important for doing all those deciding factors in highway engineering. So how it will be done, though, the factors will be analyzing the traffics, the volume counts, the origin destination surveys, so intersection vehicle arc counts. So all those parameters are very important, because particularly in junctions, in city roads, at junctions there will be multiple stuff will be happening at the same time, because the people are walking through the roads and vehicular movements will be there. So it will be very important to decide what kind of junction design we need to make. Either we need to go for a signalized junction, or it requires an interchange, or a roundabout, or even simple road markings or road signs will control those parameters. So all these factors again will be deciding on this traffic analysis and characteristics. So that comes a very important role for highway projects. So we have all the parameters, design and all. So next will be the construction. So construction, what we required is materials, of course. So as I was saying, different two types of pavements we have to construct in a particular road sections. So for that, we require all these basic materials like bituminous materials, soil aggregates, PCC, or admixtures, pavement materials, structural steels. All those materials are very, very important to get into the construction of roads. So that brief I would like to show to you. So next comes the highway drainage. This is one important factors for maintenance aspect. So uh, so it says that like biggest enemy of bituminous material is water. So as soon as the water comes along, comes in contact with the bitumens, we need to drain the water as soon as possible. So there are multiple ways to do it. One is giving the cross slope um, along the section of the road. So that cross slope we can just give and drain off those waters and collect them in the drains at the edge of the carriageway. Or you can give the cross drain along the section of the roads, depending upon the depending upon the scenario of the roads. If it is in a different sections, we can just give that one as well. Or build a culvert at regular intervals, or a small bridge, minor bridge. Those end of structure aspects also we can give and drain off the water as soon as possible. So that we need to take care while designing the highway parameters as well. So this will be the as images shows here. You can see there are different ways of moving out of taking the water out from the carriageways from the road. So next important parameters will be road markings and signs. So these are very, very important features for the road users and for his safety, as well as the other pedestrian safety as well. So it serves multi-purpose, like it gives the the road users is control over the road, and it says where to place place him in the carriageway. So where the direction will be, where it is taking it, where we need to stop, or where we need to take the left or the right turn, or where we need to maintain within the lane. So those are the parameters which controls the road users or the pedestrians will be road marking and road signs. So we need to give importance to those parameters as well. So these are some road signs which controls mainly in the intersection or in the high speed highway. We need to provide these one at regular intervals, so that uh, it helps in road safety as well as guidance for the road users. So once we have all these parameters, road maintenance and the very important factors which controls the highway project as well. Because once we construct the road, preserving and keeping each type of roadways, roadside structures as nearly as possible to its original conditions as constructed. So that will be the ultimate aim, but it can't be achieved for 100%. But subsequent improvement and operational highway facilities and a service to be provided satisfactory and safe transport is called road maintenance. So basically, we will try to achieve to closest possible to the original condition. Regular maintenance of the road. In some cases, the earthwork may be just slips off from the road sections because of heavy rain or substandard construction. So for that one, quickly reconstruction will be very much important. So in some cases, the it creates a pothole in a section. So once the pothole is created, if rainwater is collected there, it will be starting the water will be percolating through the uh, road layers, and it will create damages to the road. So quick maintenance will be helpful for the long run of any highway projects. So maintenance will be a very, very crucial process, and also it improves the economy as well, because construction takes a lot of capital to be invested for a particular stretch. So maintenance will be, if we maintain the road properly, that capital can be stopped into going into that road for any reconstruction again and again. So once we construct it with thorough planning, design and analysis, and proper with proper construction material. Once we do that, we try to maintain that one for a particular stretch. So that will lead to a good practice for any highway projects. So what I was trying to say, once we have all these parameters rebuilt, what it gives final output of the roads will be, of course, to give the country, the region, a better economy, because connecting road connectivity is very, very important for any growth of the countries. Without proper connection, it will be very difficult for any country to develop uh, in the pace what we seeing through. So proper infrastructure is a very much important, because people use this road to reach their place and do their business or do the economy their bit. So we as a engineers try to give them as safe and as quick mobility as possible to reach their destination and do their part of work. That improves a lot, because if everyone communicates with a safe and a quick manner to and fro, it definitely helps a lot of time. As we experience in our countries, city roads are jam packed, and we stuck in traffic for many hours. So that can, if we avoid that one, it gives people to reach their places, maybe it's a personal place or maybe it's a professional place, and reach them quickly instead of staying on the road. That will be leading to the economic improvement, as well as the financial growth of individual, or as well as the uh, country's growth. So that's how it plays a very important role, what we are trying to achieve here. So these are the, with that being said, these are the parameters of highway engineering, starting from planning, designing, analysis, maintenance, as well as the final output of building an economy. So these are the basic about highway engineering. So we quickly move on to the other topic of today's webinar, which is designing a highway engineering project using the Autodesk Civil 3D. So I'll quickly go through the Civil 3D overview. So once you open the Civil 3D application, so every year the Civil 3D has different versions to it. So this is the version which which we are using, like in 2019 version. So this is the parameters which you come across that them once we open this one. So I'll just try to explain what are the important factors we need to take care while once we have open these applications. So what is Autodesk Civil 3D? So Civil 3D is a design applications which works on the background of AutoCAD. So it has all the features of AutoCAD, but it has additional features for the design of the highway projects. Not only highway project, it has a rail engineering project as well as the pipe networks for the drainage design as well. So mainly we concentrate on the highway part in this presentation. So once we open this application, you will be see all the parameters in the ribbon bar here. So this part of the bar is called ribbon bar. The top the tab which says the file, edit, insert, those are all the parameters will be called as menu bar. So the same parameters are there in the below with the details of this all the tools, which is you can see in this one. So the other part will be the quick tool access bar, which normal in Excel and Word. You can see this open file, the save as, or open a new document, do undo, those kind of parameters will be there. So here is an important tab called tool space icon, which gives you this is the tool space icon. If you click this on and off, it will be showing this dialog box separately. So here is all the controls for this Civil 3D. So I'll be explaining in the further slides how it will be we use this one. It is called it has 4 sections here. One is prospector, setting, survey, and toolbar. Survey we don't use for normally, because as a highway part we will take the survey directly from the surveyor or the survey consultant. We use that one. So the highway engineering will be using the prospector tab, settings tab, and toolbar tab. So these are the controls we will do that. So coming further, this marked section, you can see this will be the highway geometric design editing tools. So where we can create all the parameters like alignment design, profile design, corridor, intersections, assembly creations, cross section developments. All those parameters will be controlled within this small area. It has a lot of features if you just drop it down. So that's one option. Quick setting options we can see in this overview option. one background I would like to say here is Civil 3D is quite a bit of intelligent software where it understands the user's requirement as such. For example, I would like to say this because once we do it as in the table of content, I said the procedures like development of DTM, development of alignments, and corridor sections. So finally, the output. So all these features or the template will be interconnected to each other. So if it says once we design and we submit to the client, and the client says no, I need to realign this one or give the radius smaller or bigger. So once we do that changes, all the parameters will be automatically updated. So in the earlier applications what we used a few years back didn't had that feature. I'm not saying the other application is not that much advanced, but that features was not there, so we need to do it all over again. So in this case, that is a very big change what we came across, and it saves a lot of time for a designer and project in the design. For the limited time we have, we need to change those factors so that automatically update will be there. So that update, what all the features, I will just say in the coming slides. So these are the advantage we have small in these Civil 3D applications. So coming back to this overview tab, so again this is the area what the black is called, which you see in the normal AutoCAD as well, which is the drawing and design part where we see do all these features. And in the bottom, like in AutoCAD, we have this command bars, and it says status bar here, coordinate display, and the navigation view cube. So these are the basic tools we use for our design help. So hope this gives you a brief idea about the application.